In this video, we are going to review multiplying polynomials, including a monomial times a binomial and a trinomial. First, let's review examples where we have a monomial times a binomial. First, let's review some of our key properties we're going to need for this section. First, the distributive property requires us to multiply the number outside into the parentheses inside. So I first can multiply the 7 to the 3n. So when I multiply, 7 times 3 is 21, so it becomes 21n. Then you're going to multiply the 7 to the negative 3, so I distribute the 7 to become minus 21. Also, when we are multiplying exponents, we can think of it as we are adding the exponents. So for example, x times x is x to the first times x to the first, and 1 plus 1 gives us this is x squared. Also, if I have x squared times x, we know it's really x to the first, and 2 plus 1 gives us x to the third power. In the next one, I have x times x to the third, which is x to the first, and 1 plus 3 gives us this is x to the fourth power. And then lastly, if I had x to the second times x to the fourth, I just add those numbers to give me x to the sixth. But the key thing is we are always adding the exponents. So in these examples, we have to distribute the number that's outside into the parentheses. So for the first one, I'm going to multiply the 4a times a. So I have 4a times a and the 4a to the negative 3. So we plus 4a times negative 3. Now when I simplify this, 4a times a, this is really a 1a. 4 times 1 is 4. A times a is a squared. Plus 4a times negative 3 is negative 12a. And instead of writing plus negative, I can rewrite this as 4a squared minus 12a. For the next example, I'm going to distribute the 7a to the a. So I have 7a times a and the 7a to the 2. So it's plus 7a times 2. Now when I multiply, this is really a 1a, so 7 times 1 is 7, a times a is a squared, and we also have 7a times 2, which becomes 14a, so 7a squared plus 14a is my final answer. In the next example, I'm going to follow the same process. So I start by multiplying the 3n to the 6n, and then I'm also going to distribute the 3n to the minus 5. So it becomes plus 3n times negative 5. Now when I simplify, 3 times 6 is 18, and n times n gives me n squared. For the next part, I'm just going to multiply, so the 3 times negative 5 is negative 15, and I leave the n attached, and instead of writing it with plus minus, rewrite it as 18n squared minus 15n. For my next example, I start by distributing my 7p to the 2p. So I have 7p times 2p, and I also distribute the 7p to the 2. So it's plus 7p times 2. Now when I simplify, the 7 times 2 gives you 14, and p times p is p squared. For the second part, you also have 7 times 2, which gives you 14, and the p is just attached. So your answer is 14p squared plus 14p. Now we're going to go through some examples with higher power degrees, but we're following the same process. So I multiply the 4r squared to the 4r. So I have 4r squared times 4r, and the 4r squared to the minus 4. So plus 4r squared times negative 4. Now when I simplify, 4 times 4 gives me 16, and r squared, we know this is really an r to the first. If I take the 2 and the 1r together, it becomes r to the third power. Then for the next part, I have the 4 with the negative 4, so it becomes plus negative 16, and the r squared is going to stay attached. Now rather than writing as plus minus, it becomes 16r to the third minus 16r squared. For the next question, I'm going to distribute my 6p to the third to the 3p. So you get 6p to the third times 3p. And I'm also going to distribute the 6p to the third to the minus 7. So it's plus 6p to the third times negative 7. Now if I simplify that, 6 times 3 gives you 18. And we know that p to the third times this 1p, which is p to the first, the 3 and 1p combined to become 4p's. So it's 18p to the fourth. We also have that I'm going to multiply the 6 times negative 7, which gives us negative 42. So it's minus 42. And we leave this as p to the third attached. The last thing I'm going to do is, rather than writing this as plus minus, is it becomes 18p to the fourth minus 42p to the third. In the last example we have, we're doing the same process. So I multiply the 5p to the fifth times p. So you get 5p to the fifth times p, and the 5p to the fifth to the 3. So it's plus 5p to the fifth times 3. Now when I simplify, this is really a 1p. So 5 times 1 gives you 5, and p to the times p, which is really p to the first, the 5 and 1p combine to be 6p's. So it's p to the 6. For the next one, I multiply the 5 and the 3, so it becomes plus 15, and I just had the p to the fifth attached. So we see in each of these cases, while it's different examples with higher power exponents, we're just following the same process. Next, let's do a few examples where we have a monomial times a trinomial. So first, when we're applying the distributive property with trinomials, as a reminder, you're distributing this 2 to every term. So I distribute the 2 times the 7x squared to give me 14x squared, the 2 to the 8x, so it's plus 16x, and the 2 to the 4, so it's plus 8. So while there's 3 terms, we're following the same process. So first, let's go through some examples with this process. So if I start by distributing the 3b, I multiply 3b times b squared. Then I distribute the 3b to the 8b, so it's plus 3b times 8b. And then I multiply the 3b times the minus 6. So you have plus 3b times negative 6. Now when I simplify that, this is really a 1b. So 3 times 1 gives me 3. And this is b to the first. So b to the first and b squared, I have 1b and 2b's, becomes b to the third. Then I can multiply the 3 times the 8. So 3 times 8 becomes 24. And b times b, these are really just 1b each, so it's b squared. And then lastly, I multiply the 3 times negative 6, so it's minus 18b as our final answer. Then for the next one, I'm going to follow the same process. So I multiply the 4x to the 6x squared. Then I multiply the 4x to the 7x. And the 4x to the minus 2. So when I do this and I simplify, I do 4 times 6 gives me 24, and this is x to the first. So x to the first times x squared is x to the third. Then I have 4 times 7 gives me 28, and these are both x to the first power, so the two x's combine to be x squared. And then lastly, the 4 by negative 2 becomes minus 8. There's just one x, so it's minus 8x as our final answer. Now when I have a variable greater than just x or whatever variable it may be outside, we're still going to follow the same process. So I multiply the 8p squared times the 7p squared. So you get 8p squared times 7p squared. And then I multiply the 8p squared to the minus 3p. So plus 8p squared times negative 3p. And the 8p squared to the minus 6. So plus 8p squared to the negative 6. When I simplify this now, the 7 times 8 gives you 56, and p to the second and p to the second combined becomes p to the fourth. Then for the next part, the 8 times 3 becomes minus 24, and this p to the second, and this is really p to the first, becomes 3p, so it's p to the third. Then lastly, the 8 and the negative 6 multiply to become negative 48, and there's just a p squared attached. So our answer is 56 p to the fourth minus 24 p to the third minus 48 p squared. In our last example like this, we're multiplying the 7b to the third times b squared. You have 7b to the third times b squared, and then the 7b to the third times negative b, so plus 7b to the third times negative b, and 7b to the third times negative 2. Now when I multiply, this is really a 1, so 7 times 1 becomes 7, and 3b's and 2b's combine to be b to the fifth. Then we know this is really a negative 1, so 7 times 1 is negative 1, or negative 7. And b to the third and b to the first combined becomes b to the fourth. And then lastly, 7 and negative 2 multiplied to negative 14, and it's b to the third as your final answer. Now let's go through some examples with multiple variables. When I have multiple variables, I'm going to follow the same process. I'm just a little more careful with how I combine them. So I'm going to multiply the 5y times 6x and the 5y times minus 5y. But now when I combine them, 5 times 6 multiplies to 30, and x and y can't combine, so it just becomes 30xy. Then I can multiply the negative 5 and negative 5, so it becomes negative 25. And now I have two y's that I can combine, so it becomes y squared. So you get 30xy minus 25y squared. For the next one, I'm going to distribute the 7xy to 2x. So 7xy times 2x and 7xy to 8y. Now when I multiply, 7 times 2 gives me 14. And now both of these have just one x, so it becomes x squared with just a y. Then if I multiply 7 times 8 becomes 56. There's just an x, however these both have one y, so it becomes y squared. So you have 14x squared y plus 56xy squared. In our last two examples, we can see that these both have multiple variables and I follow the same process. However, where they differ a little bit is when we simplify. So if I focus on the first one, once I distribute there, I'm going to multiply. So 3 times 7 becomes 21, and x to the third and x squared combine, so they're x to the fifth. Then I have 3 times 6, so it's plus 18. Both of these have an x, so the x to the third and the x can become x to the fourth, and there's just a y, so it's x to the fourth y. And then lastly, I can multiply the 3 by 4 to become plus 12. And the x and the y's are different, so it's going to become x to the third, y squared as our final answer. For the other example, in the first part, when I multiply, 2 times 6 becomes 12. And then we can see that these both have an a, and this is really a to the first. So this becomes 3a's with one b attached. Then I can multiply the 2 and the negative 7, so it's minus 14. I can combine the a's, so they both have one a, so it becomes a squared. And they both have one b, so they're both b to the first power, so it becomes b squared. And then the last thing is we multiply, so this is 2, and this really has a 1 in front of the b squared. So 2 times 1 becomes plus 2. There's no a's, however, these both do have a b. And this is b, which is just b to the first. So b to the first and b to the second becomes b to the third as our final answer.